Okay, welcome everyone. We want to start right away with this 1-hour webinar that we prepared for you. OpenVMS for Linux users. My name is Christof. I'm sort of a VMS veteran. I've been working with VMS back in the 80s of the previous millennium. 1982, 1983, I started working with VMS 3.7. Quite some time ago. And I've been working through the 80s and the early 90s, and then I personally changed over to Linux myself. So I did transition from VMS to Linux, sort of, at the time. The transition now that we want to do is the other way. I mean, we had courses years ago that we were teaching Unix for VMS users, and now we're doing the opposite. We're doing the VMS for Linux users. Right. So what are we going to talk about? We want to talk about basics today. At the time, we used to have 3 5-day courses to teach VMS. The first week was more how to handle VMS system, like what we're talking about today, briefly. And then there were sysadmin courses, 2 different types, and performance and management. And I was thinking, what do we do? What do we talk about in this 1 hour? And so I thought about these basics about logging in, because there are some details about logging in that we need to be aware of working with VMS. Then how to get help. In Unix or Linux, we have the manual pages, and there's also help available. I need to talk about that a little bit. And majority of this first half hour will be about elementary file tasks, working with the file system. So the VMS file system is quite different from what we are used to in Linux. So that was the basic idea here. And we also need to talk about a specialty in the VMS operating system called symbols and logicals. And they are mostly in the context of files and the file system. So we'll add this then to the elementary file system tasks. And then a brief outlook about editors. And Veli will be talking about later on about system files, which files are important in the operating system, where are they, what are they doing, but he'll gonna explain that to you in more detail later on. So let's get started with what happens when we log in. And I mean, there's no surprise here. We have to authenticate ourselves to the operating system, entering a username and a password. And in the very early days, when it was VMS 3, there was a default password for the system administrator. The default user was system, and the password was manager. And folklore is that most system administrators never bothered to change the password. So whenever you saw a VAX system, you just entered system and manager, and you were in. So that was the story at the time. But in fact, VMS is a very safe and secure operating system from that point of view. If you forget the password, you have forgotten the password. There's no way how to easily recover the password. There might be a way how you can overwrite the user authorization file and replace it with a version that you know. But then of course, you need access to the physical machine itself, and that would be a way to break in. But other than that, you can not really modify a password if you don't know the previous password, and the uh, user account can also be secured with what is called a secondary password. So a secondary password is a bit like what you can think of in the old Cold War days, that you needed two keys to launch the missile. And same idea was here, that there are two separate users knowing a password each, and the one enters the first password and the other one enters the second password. Yeah. So from that point of view, VMS is quite secure, and yeah. So that's about username and passwords. Just a couple of words. The usernames traditionally were all in uppercase, and so were the passwords at the time. Now, OpenVMS is more modern in that concern, and the OpenVMS accepts also lowercase when you enter the username, and the password can be mixed case. So this is a bit a thing of the past, that passwords would not be case sensitive anymore. So they are case sensitive. But when you log in and you get the message, login failure, or login denied, or what was the message again? Don't recall now. And then several reasons might be the culprit here. The first of all is you entered the password incorrectly. You have a typo. Yeah. And the typos, then of course you can correct. But also, if you have a maximum number of login failures, yeah, then the account is automatically disabled. Yeah, so this was our favorite prank back in the days, that the colleague, we didn't know the passwords, but what we did was we entered the password 3 times incorrectly, and so they were locked out, and they had to go then to the system administrator. So that was also a bit of an annoyance, even though it is a security feature that the account can be automatically disabled when when you have a maximum number of login failures. Yeah. And also the system administrator can choose to disable the user. Yeah. So you could enter the password and just says login failed, or yeah. Right. Also, what VMS introduced at the time was that you could restrict the access times to, there were primary and secondary days that you can define, and you can then also say at certain times on primary and secondary days. Yeah, so this could also be a reason for a login failure, because you're not allowed to log in at that time of day. Yeah. Right. So that's the first hurdle to overcome to get access to the system. Once you're logged in, then your account also has a default set of privileges, and it also has a set of authorized privileges. Yeah, so the default privileges, they will then be set when you log in, and the authorized privileges would then allow you that you can elevate your privileges with these specific privileges. But we don't want to go into detail about the privileges here, just go too far. Yeah. But the machines back in the days, they had limited memory, and they had limited disk resources, and so the accounts also had restrictions. They had quotas for the working set and for buffered I/O. So there were a lot of limitations that you could define for the processes or for the users that were running the processes, and then just to organize yeah, the operation on that machine. Yeah. Right. And once you're logged in, or when you're in the process of logging in, then it tells you when your last login was and when the last non-interactive login was and how many login failures you had. So these were the 3 lines that were then displayed. Yeah. Okay. So once you're logged in, yeah, then you are presented with a prompt, usually $1. Yeah. But this prompt can also be changed with set prompt. Yeah, so you can define your own string and you can augment the prompt if you like. And in contrast to Linux, yeah, and the Linux operating system presents you with a shell. The way the shell works is you have a predefined path. If you enter a word in the shell, then the path is then searched for a program that matches this word. Yeah, so this could be anything in your path, which is a blessing and a curse, of course, but the blessing, you can always create easily a new command by placing a program in your path or in any of the directories which are in your path, and you have a new command. Yeah. Now the DCL is a little bit different here. You can only execute or can only run defined commands. If you enter a word or a command that is not defined, it comes back and says unrecognized command verb, yeah, check validity and spelling. Yeah, so that is one of the major differences that we find between the DCL, the command interpreter of VMS, and Linux. I mean, there are ways how you can define commands, yeah, but again, that would lead too far for a first day introduction. Yeah. One thing that you can also do is you can abbreviate commands. Yeah. For example, there is a command called directory, for listing the directory, but directory is a very long word, relatively long word. So you can abbreviate it. You can say dir. Yeah. And I think DI works even because the rule is as soon as the command becomes unique or becomes unambiguous, it can be executed. Yeah. If there were 2 commands that start with the same prefix, then it would say ambiguous command verb. Yeah. So you would have to be more specific then. Yeah. But again, we have to, we can only execute a certain set of commands which are predefined in the DCL. Yeah. Right. Now, if you want to run then an executable, normally you would have to use the image activator, which is the run command. Yeah, with the run command, you can then specify which executable should be loaded and executed. Yeah. Also a bit tedious if you always have to say run and then the file name, if it's a very long file name, then you wouldn't be happy to enter this command every time. So you can define symbolic names. Yeah. A symbolic name is defined as a character string. Yeah. And this, if it's preceded with a $sign, yeah, before the file name, then you would have a symbol which would then act like an executable. So it's a bit like the alias function, sort of, yeah. But these symbols can be used for even more. You can have also an integer value in the symbol name, or you define a symbolic name yeah, for any kind of character string where you want to have a substitution. Yeah. Yeah. And so, so this is kind of the first steps that we can do in the DCL. We can run our commands. Yeah. Yeah, commands can be abbreviated. I was mentioning that already. And run command. There's something. Let me see here. This is a kind of repetitive. There's something happened here that the slide is duplicate. No, sorry for that. One thing, the last point that I wanted to mention as well, if you want to remove one of these symbols that you defined with symbol name equals expression, you have to use a command. You have to say delete/symbol. Yeah. Yeah. There's also just thought of it. There's two different levels. There's a local level for symbols and a global level for symbols. And on a global symbol that must be deleted with delete/symbol/global. Yeah, right. So these would be the first steps that we do in the DCL. I was talking about help just a minute ago. Help is available with the command help. And because your screen has only a limited number of lines and limited width, these parameters, they are part of your terminal definition. And so within these parameters, your page is then formatted for the output. So it's automatically paged, so it does not overspill and you don't have to pipe it through more. Yeah. So that's also a difference in between the manual pages in Linux and the help in OpenVMS. Yeah. So the commands that you can get help on, they are at kind of a top level. Yeah. So when you enter just the help command at this level, and it lists you then the topics available here. Yeah. Then you can select a topic, and a topic can have a subtopic, and subtopic can have subtopics themselves, and so on. So it's a bit of a recursive structure that we find here. And you can then go deep into this dungeon of help topics and subtopics. But if you press enter when you're in a subtopic, you go one level up. And most topics in help have two subtopics. One is called parameter and one is called examples. And you can get the help then that you expect from the this help system. It's quite useful. And sometimes you forget what a certain qualifier does. So that would be the help. Yeah. But now to the core of what I want to talk about. A major difference between Linux and the file names in OpenVMS. In Linux and Unix, the structure is comparatively simple. You have a recursive structure of a directory, subdirectory, and so on. And file names are just a sequence of characters. Yeah, so there's no special differentiation. What would be the name for a directory? What would be the name for a text file? What would be this and that? It is quite open. Yeah. So, not so in OpenVMS. You have a very strict pattern, and this is displayed here in the top line of this slide. Every file name would have or would start with the node name. Yeah. not necessarily. If you work with files on your own node, then this can be dropped and the node name would be assumed that it is the equivalent of localhost. Then we find files on devices. So the device name would be the next entity that we have in this structure. And before I forget, the node name and the device name are separated by 2 colons. Yeah. Then following the device name, on a device with a file system structure, we have a directory structure. And the directories, they are mentioned and listed in these square brackets. Yeah. And the separator of the directories is a single dot. Yeah. So this would then be the equivalent of we start at the top level, yeah, and then we drill further down into the file system recursively, and the separator character would be a dot. Yeah. And then once we have arrived in the directory where we locate our files, then we have a file name followed by a dot, followed by an extension. I mean, the extension can also be empty, but it is part of the file name. So the dot itself, yeah, must be mentioned at least if the extension is empty. Yeah, so you cannot have file names without a dot. Also a big difference to the Unix way of doing things. Yeah? And the other curiosity is that you have then a semicolon as a separator and a version number. Yeah? The files in the OpenVMS file systems, when you create a new file with the same name, it automatically receives a new version number, yeah, one higher than the current version number. And the previous version is always kept. Yeah. And there are ways, we will see that in the next slide, how we can remove all files except the most recent version with just one command. But we have this behavior in the VMS file system that we have file versioning, yeah, and we keep these versions. Yeah, so you have to then make sure that when you edit a file, you save it, you automatically have a new version. Yeah, you compile the file, you automatically get a new version of the object file. You link a file, you get a new version of the exe, and so on. So this is, as I said, a different behavior than in the Unix file system. Yeah. And an example that I have here is, so the node name would be impitu, the device name would be DKA0, the directory name would be sys0 sysmanager, and the file name would be sysstartup_VMS. The extension would be com for command file that Veli is talking about in a couple of minutes. And the version number would be version number 9. Yeah, so that's an example for a complete file name. Yeah. And if you do not specify any of the entities, then it would assume your current setting. Yeah, so I'll explain this in the next slide a little bit better with examples. Yeah. Right, now there are two special directories I want to mention briefly here. This is the directory with 6 zeros, which is actually a combination of 2 octal numbers. This goes back to the times when we were working on PDPs, PDP 8, PDP 11. There was no directory structure. There was only a directory in the top level, and each directory had the UID and group ID of the user. Yeah? So it has a bit of a history, but I think I digress now a little bit away from OpenVMS. So that would be a topic of another talk, maybe. Right. Now, it would always be difficult if we had to always define a file name with all these parameters. Yeah. So what is used heavily in this context is what is called a logical name, because logical names are more expressive and allow you to navigate through the file system T much faster. Yeah? And there are two commands that create logical names. One is called assign. Assign creates a logical name, and define does a bit the other way around. It associates an equivalence name with a logical name. Yeah? And for logical names, we have four different tables by default. You can create more tables if you like, and if this helps your day-to-day operation. But by default, there's a system, a job, a process, and I forgot the last one now, a table. And logicals will be defined for one of those tables. The traversal through those tables can also be altered if one requires so. But mostly the system table will be traversed first. Yeah? Or was it the process one? Not 100% sure. I have to look that up. Nevertheless, you can list the logical names by saying show logical, and then you can follow a trail. Like in this example, there is a logical called sys$system, and sys$system, the logical then translates to sys$sysroot sysexe. And when you look at the logical sys$sysroot, then you see that sys$sysroot is then DKA sys0, or syscommon. Syscommon would be DKA0 sys0 syscommon. So when you say list me the directory sys$system, you in fact list DKA0 as the device name, sys0 sysexe. Right. So the point is that you translate the logical name into that format of a file name here in a directory, on a device, on a node. So that's important about logicals. And the elementary file tasks that you apply to the files in the file system. The first command would be directory that I was talking about. Remember, command names can be abbreviated. And what I omitted earlier was that you can modify the way these commands operate with qualifiers. And the qualifier will always be added to the command name with a / and the qualifier itself. So a directory has more than these qualifiers. You can look it up in the help. And it would be directory full, gives you full information about a file. Very expressive what directory full lists. And you can only look at the protection codes and who is the owner, what is the size of the file, when was it modified, the date. The date itself can also be qualified even further, that you see different timestamps. And you can combine qualifiers if you like. Yeah, you can say directory /owner/size/date, and then you will have the corresponding output. Now, an important command is set default. Yeah, set default will change your current directory. Yeah, when you log in, you have a default directory, yeah, which is a device name and a directory name. And if you want to change the directory, it's not CD, yeah, it is set default. Yeah, so your default directory will then change when you apply that command. And then set default. There is an example on the next page, because you have wildcards and special characters how you can navigate. If you just say set default, then it wants to know where to. There's no default for setting your default. Yeah, if you want to go to your home directory or to the standard directory, you have to say set default sys$login. Yeah, and then you can navigate to a subdirectory, or you can navigate a level up. If you are in a subdirectory, you want to go to the parent directory of that subdirectory. Yeah, that's probably better shown in a demo. Yeah. Then the copy command copies files from a source to a destination. Yeah, so that's pretty straightforward behavior. You can also augment copy with a /log qualifier, so it will tell you which files were actually copied. And you can give wildcards. Yeah, we have more examples on the next slide. But the % would be a single character, and the asterisk would be multiple characters. Yeah. And also another behavior that we can observe here, if we want to copy a directory, yeah, then we have to actually do this in a two-step procedure. First, we have to copy the directory file. Yeah. In this example, the directory monkey and the directory Smith, yeah, will be copied to Jones, into the directory of Jones. And then we can copy the files from monkey in Smith to monkey in Jones. Yeah, that's another example where VMS differs from Linux very much. Yeah. And you can use the command rename for renaming. Yeah. And again, if you do not specify an entity in a file name, then it will be assumed that it keeps it. So the rename average.obj to old average, yeah, will actually then be named old average.obj. Yeah. So the commands, when they work on file names, they will keep parameters. This is also different from the behavior that we know from Linux. Yeah, Linux just copies names, and then it takes the names literally. The DCL in VMS, you have a specific context, and this context is then used for the naming of the files. Yeah? It's very important to not to forget that. Yeah? So rename does what it says there. It renames files. You can also move files by renaming them into a different directory. Yeah. It's also possible. Yeah. Then we have the command delete. Yeah. And we have a command called purge. And purge is the command I mentioned earlier. if you have multiple versions of a file, then you can say purge this file, and it will delete all versions except the most recent one, the one with the highest version number. Or if you use the /keep qualifier, you can say, I want to keep the last 3. Yeah, so this is also possible with the purge. Yeah. And to change the file access, yeah, the protection, you would use the command set file /protection. And you can list who has access to the file. This would be show security. Yeah. So this should get you kind of started. If you get your hands on a VMS system, and you could use this as a kind of a cheat sheet and then try out these commands, you know, and then see what's happening. Yeah. Right, I have to hurry up a little bit, otherwise Veli doesn't have enough time to explain the files. Just quickly on wildcards. When you look at the second from the bottom directory, there is square bracket dot square bracket close, and that would then list all files and all the subdirectories. So this would be kind of a recursive directory listing. Yeah, so you can use the dot to drill into the directories. And if you look at the example set default dash dash dash, that would actually go 3 levels higher from your current directory. So each dash takes you back 1 level. It's to one parent directory. Yeah. Okay, one last slide would be about editors. Yeah, now the use of editors, old one would be EDT, the edit EDT. The modern one with version 4 was TPU, which is still available. You have Emacs if you want, available in OpenVMS, and you have language sensitive editor if you work with source code files. The language sensitive editor will recognize which programming language you're working on, and it will support you then in editing these files. But they also would be better shown in a demo, and you would want to see it then working yourself. Right. I would delay the demo until Veli has shown you his presentation. And for the moment, I say thanks and hand over to Veli.
Hey, thank you. Let me just try to share my stuff. I hope you can see it now. Hey, my name is Veli Körkkö, and I've been working on VMS since maybe late 80s, so I'm kind of youngster to compare to Christof, because he's been over here over 40 years and I'm still coming up to 40 years. Okay, but let's go on forward. Okay. The one big thing, the way VMS is different when coming to Linux is that, or your basic Unix is that, as far as, well, over the years that I have touched Linux systems, you install stuff and you hardly ever have to edit any files. Just magically things get started when you reboot the system. That's kind of different when it comes to the VMS. We have here a number of system startup files that are basically text files. this .com. It doesn't mean the same thing as it would mean on your Windows box, and I presume .com doesn't mean anything on Linux system, but in this context, on your basic VMS system, this .com is basically a text file that is containing operating system or digital command language, DCL commands that can be executed. So in no specific order, some of the key files are in sys$manager location, logical name sys$manager, that typically is on your system disk in, say, opening bracket sys0.sysmgr closing bracket, or opening bracket sys0.syscommon.sysmgr closing bracket. These files are syconfig, sylogicals, sypack svp files, sysecurity, and most notably systartup_vms command. And since we are sometimes interested about shutting down the system cleanly as well, it might be useful to mention that the file to be edited with your own stuff that you want to have executed on system shutdown time, that would be sys$manager sy shutdown. Okay. I'm trying to speak up. I don't know which one of my mics is where it is really, so let me see. Okay. About sys$manager syconfig.com, am I more audible now? Hello? This is basically how it looks as out of the box. It has just some explanatory comments, and on the next slide I will show what, for example, what you might have in there. So this would be typical place to have your stuff loading, for example, some specific drivers that are not going to be automatically loaded. This stuff I have actually taken from systartup_vms.com, but presumably, in my opinion, it might be better placed in syconfig.com, but this just goes to serve the kind of stuff I might have in here. sylogicals.com is another key file, and this is more commonly to be edited because this file, the template file out of the box, as it comes in your system, it contains examples how to define the location of various key system files, like system authorization file, that is the sysuaf, or the alternate system authorization file, automatic login file, sysalf, rights list database, proxy files, stuff like that. Not necessarily needed on a basic single VMS system but if you have a cluster, and especially if you have a multi-architecture cluster or cluster with multiple system disks, like, for example, you most definitely would have if you cluster your two x86 systems together, they'll both need their own system disks. So this file is to be used to define location of your key system file. System files like the one defining usernames and passwords. SysUAF would be kind of equal to your /etc/password file. And for example, even on a single system image, single node, it might be useful to edit this file properly, that sylogicals.com properly, so as that you avoid what I show here. If we don't have that sysuaf logical and I try MCR authorize, most likely it will complain that it's unable to open the system authorization file and it doesn't find, and it asks, would I like to create a new file? Because the file normally resides in that sys$system. And so if we have that sylogicals.com properly edited, then we can just run the authorize and we don't have to change our default directory to the sys$system directory. sypack swapfiles.com. This is where we define, where this basically can be used for defining our swap space. So typically the page and swap files reside on your system disk in the expected locations. And if you are running out of system disk space or for performance reasons or for whatever reasons, you would like to have your swap paging space files relocated to somewhere else. Typically, this would be the file to be used for that purpose. Here I am showing an example of DCL command show memory/files, and this shows my page file in the usual out-of-the-box location. The size here is shown as 1 and number of zeros, that is presumably 1 million pages. The actual file on the disk is 16 million disk blocks, approximately. This is another example of show memory/files. That this I included because this resembles the way your out-of-the-box system would come out if you have VMS installed, and it's kind of, well, you haven't tuned it properly. So what I have seen so many times happen is that your swap file is way too small. In good old days, you would have problems because of that, but most likely not nowadays. systecurity.com, well, there's a file. I have personally never seen any use for this so far, but it might be useful. And then our key main file, sy startup_vms.com. Unlike your basic Linux box where you install software and all those startup files to be executed are put in some magic place that I can never find. And this is the text file that you need to manually edit and presumably have all kind of oddball stuff in here. And I'm just showing a few lines what I tend to have there. So, for example, the almost very first thing that I do during the system startup is to execute this set logins/interactive equals 0. This then would allow me to log into the system while it's still struggling to get up if I have an account with Oper privilege. There are more example commands. So here, for example, here define/system $batch line and the next line kind of create a batch queue so that I would be able to submit some of the actions to be done during the startup into a kind of startup time batch queue. Batch queues are VMS equivalent of cron, but they are, well, personal opinion, they are so much better. And more examples of commands what we can have in our startup file, sy startup file. Still have some 8 minutes to go and more stuff. And then as pretty much at the end of the startup file, we tend to have this startup $interactive underscore logins symbol equated to some number so that when VMS startup actually exits this size startup underscore VMS, it will set the login limit to that number. And in this context, this system that I have this example from has very limited number of interactive users. So this 32 is way, way, way bigger than I will ever see. And since I tend to like to be notified that my system has maybe expectedly or unexpectedly completed, well, rebooted or whatever, I tend to have a mail sent to myself just to notify me about. SY shutdown is a place to have commands that you might wish to have executed during a shutdown. And here's just an example stolen right out from VSI. If you install this VMS SPI product, then you might wish to have these commands in your syshutdown.com. And to execute the system shutdown, you execute this command procedure. Oh crap, there's a mistake. Well, okay, there's no mistake. This is, I'm misreading my notes. You execute that command @sys$system :shutdown, and then it asks a few questions. And there's the, do you want to invoke site-specific shutdown procedure? Yes or no? And that would be that sys::manager :sy shutdown.com. So when shutting down the system, you can bypass executing your site-specific or node-specific shutdown procedure, or you can have it executed. Another key system file, I still have a few minutes to go, is sys::system :modparams.dat. This is yet another editable file onto which you can embed your requirements as two key system parameters. So, for example, on the next slide, I will show this. This is probably the way some of these lines come automatically in there when you install your VMS system. So, for example, in here, it tells me there are comments, and then there it says VAX cluster equals 0. Would this be a clustered system? But that line would be probably VAX non-zero value. The node name of the system ID, and then some key parameters, just something equals value. So allocation plus equals 1, shadowing equals 2, and so on. And maybe some directives for AutoGen, like page file equals 0, doesn't mean that I want to have my page file as size 0, but there are instructions to the AutoGen not to mess around with my size of my page swap or dump files, that I have set them the way I want them to be, and I don't want AutoGen to play around with them. Okay, do we still have some time left? Or do I need to skip this backup stuff? Hello? Okay, very quick.
Not sure, Veli. I was going to show the last couple of minutes a little bit on a VMS system, if you don't mind.
Yeah, okay, fine. So maybe I'll hand over to you then, and I'll have to skip this. I wasn't fast enough, sorry.
No, that's fine. You just need to stop your share.
Yeah, okay, I'll stop my share, and then it's all yours.
Okay, thank you. And I'll do, where is it? Would be here. There was one question that I didn't answer yet. There were a couple of questions. I hope I answered them correctly. John, you were asking about the file version limit on VMS, if it's still limited to 4096. And the answer is it's 32,767. And Hans answered this as well. You can, though, limit it for an individual file, set file / version limit equals such and such. Yeah. And yeah, it's an assigned short integer. I would say that is the limit here. And then Tobias was asking if you can delete with a single command. There is actually in OpenVMS, you can do a recursive delete. That wasn't possible in older versions of VMS, and so many people wrote utilities like del tree that you can just enter the name of the directory file, and then it would delete the tree below it. So if you look at the old Decus tapes, you can find a few utilities which will do exactly that. But the delete command actually now does do that. That was, I think, added sometime in the 90s or in the noughties, if I remember correctly, because that was a function that was requested very frequently. Yeah? And so you could then, did I get this question right, that you can do this in a single command? Good question. I would think yes, yeah, that it does this, but I would have to try this. Yeah. Okay, I'll check this out, Tobias, in a second. Okay, and then there was a question, Ildus, you were asking, can 0,0 be used instead of the 6 zeros in the path? This is true. Both names mean the same, yeah, because it's two octal numbers that you combine with the comma, because the two octal numbers are actually the UID and group ID pair of the user, how it was on a PDP system. Yeah? And the 0.0 was for, I don't recall now exactly if it was for the system, but this would designate the top level of a device file of a device that has a directory. But Hans is also has added here that you cannot use this in a logical. So you cannot have systola sysroot 0000. Yeah, so this only applies to devices, as far as I know. Yeah. Yeah. Yeah, Robert. Thanks for the clarification here. The master file directory. Yeah. But the answer to your question is 0,0 can be used instead of the 6 zeros there. You know? And you also have a pending question that I haven't answered: how to get the exact path without any logicals. There is no direct command, to my knowledge, that does that. You would have to actually dissect every logical. You have to translate every logical yourself, and then if the logical contains a logical, like in the example that I showed you, you then have to do a second step and then ask, what is this logical? But the standard commands, they do not resolve this recursively, that if you have a logical within a logical within a logical, yeah, that you just say, what is this path without any logicals? Yeah, that command, to my knowledge, doesn't exist. Yeah. Yeah. It is, in fact, the $f translate logical name. Yeah, that's the system service that does that. But does it do that recursively, Robert? I'm not sure if it does that. Yeah, not 100% sure. I don't think it does. Yeah. Oh. Mm-hmm. Okay. That would need. I would need to follow up on that. Yeah. Yeah. Show on systole sysroot. Yeah, well, it does say if I well it does say that systola sysroot would be systola common and it would be DKA 0. But if you look at systola system, systola system is systola sysroot sysexe, and will this then be resolved to the full device name? Or will it just do the one level, go to systola sysroot? Yeah. 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 Does it do that with a, let me see, show logical full systola system? Hmm.
Well, it doesn't translate all the logical names because it still the translation contains that systola sysroot.
Yeah, it still contains systola sysroot, but if I say, when I say show logical full systola sysroot, yeah, then it tells me from the system table there are two ways. Yeah, here it also has systola common, and it continues here. So that's, I think that wasn't the question. It was, if I give systola system, will it tell me the full name, meaning this one here? So what expected was impetu $DKA0 sys0 sysexe for systola system. That, I think that was the question, and I don't think that it does that. Yeah.
And besides, there's that concealed and terminal. Some of those things are there that are specifically there so that you wouldn't, that the actual content would be kind of hidden purposely. But anyway, I digress.
Mm. Okay. Right. So where are we? We are already a little bit overdrawn, so I don't know if I could show you a little bit. What I have is, and I have a system here prepared that is an OpenVMS system, and you see that you can also log in via SSH. So this is from a Linux system. You can log in via SSH using an identity that you have stored as an authorized key. Yeah. So in the authorized keys, I have them matching public key. And you see, you get the welcome message, you get the listing of the interactive login when your last non-interactive login was. Then you have your user is then set to a default. Yeah, again, there's a logical here. You can ask, what is disk $user? Then it tells you it's a specific device. So if you look on the device 100, that would be equivalent. Yeah, so DKA 100 would be equivalent to disk $user. So you would get the same output. You would get the same output here for either saying referring to this logical name directory or this device name directory. Yeah? And to shed some light on the 0000, so there is a directory, this 0000, which is the top level. And of course, I don't have any privilege here. I have to go here and do the same thing, disk $user. Yeah, and you have then the top level where you have system files, and you have a directory called xof.dir, and the dir directories, they are directory files. So kits would be another directory file here. And if you do this on the system disk, which would be DKA0, then you see that you have the sys0 directory, which contains the operating system. You have another directory, VMS $common. You have TCP IP DHCP directory. There are several directories here on the system disk when you use the 0000. And again, this is equivalent. Yeah, if you use the device name comma 00, yeah, 0,0. That's what I meant. Yeah. Okay. Right. It would be nice if you could try this yourself. What I have created some time ago is a Docker container. Yeah, so I don't know if you would be interested in how to start a Docker container running VMS 4.7. Yeah, this is a very old version of VMS, but for trying out various file system operations, for learning how to deal with the logicals, that would be a good environment. And it's a container. So you could, oh, let me see, where am I going now? Why not here? I have to share another window. Hang on. Two seconds. Share window. That would be that window that is shared now. And you can do a Docker run, and it would be x of d6w slash vex VMS. And this starts then an emulator, and it should actually work. Oh, I haven't tested this in a while, but anyway, I'll fix that so that you can actually run this particular container. And what it creates is it runs a simulator of an ancient VEX 11780, and the username would be system, and the password would be manager as per normal. And you could experiment with that. Yeah. So apologies for that. Why does this not work? Oops. Let me see. No, it does not work. You know, what it tries to do is it tries to attach a device and that doesn't work. I have to take this out. I'll fix that for you, and then you can use that command in order to experiment a little bit with VMS. Yeah. Right. So yeah, thanks everyone for attending, and sorry for the overdraft a little bit, but yeah, let us know what you think.